Greetings, everybody. We're in module 6 of kernel block 9. It's August 29th, and it brings us closer to the home stretch of kernel. This is how we described the week in the weekly email that came out on Sunday. And I want to read from it a bit as a means of starting, of just kind of like where we are in the program. So it says, so far we've explored a planetary scale decentralized networked virtual machine, which provides a shared ownerless computing surface on which we can run a new financial system, reimagine the web, our organizational, perhaps online customs, along with altering or nudging societal incentives. In Module 6, we consider how we can encourage the interpersonal trust required to play principled infinite games with each other. What do principled games look like? How might these types of games be propagated together? And what struggles might we come across along the way? The module is written contextually as a kind of like exploration of scaling and like what it means to scale this planetary ledger. At the time that it was written in 2020, 2021, the Ethereum 2 had not shipped. We kind of had Ethereum, this virtual machine that was kind of working, but gas prices were always somewhere in the $5 to $7 range. Couldn't really use it all around the world and in most application capacities when costs per transactions were so high. And so the first curated reading of the week was about the Ethereum 2.0 design rationale, which was a big push at that time period. But ultimately, like this idea of like scaling is something that we're thinking about in multiple terms. And I think we have one of the best Fireside guests really in the world to explore this specific module here today with Coogan Brennan. So we'll get to him in a minute. But to explore the module is to explore scaling in depth. Like where are we in the story of scaling, let's say Ethereum, which was the first place where we've started in the kernel syllabus. What does that look like? And then to like broaden back out to the question of like, well, what are these principled games that we might be interested in scaling on this machine that now does have more capacity than it once did? So first we'll actually talk about practically what does it take to scale and what has been done, what are the mental models to do so. And we'll talk about like the two curated materials of the week, hopefully with many voices as is the norm in Fireside. So the two modules for the week were on censorship resistance and on learning how to learn. The interesting part here that came up in our conversation Wednesdays, Junto, was on feedback loops and opponent processing. And it says things like we need to cultivate ecologies of practice in order to both refine our ability to meditate or contemplate within a world, as well as engage with it via effective relationship and action. Talks about these programmable incentives that encourage censorship resistance and the way that we can speak greater truths. And then in learning, just talk about like what it means to learn and to know more. The part that I want to kind of like start with here is this sense that learning how to learn is a practice that is built on a deep trust in what we would call the underlying pattern. You have to trust that you'll come to know what you need to know when you need to know it. This trust creates the necessary neurological conditions for useful knowledge to take root. The rest is practice, 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 until you realize that there is no difference between practice and perfection, that what you most wanted to know was here all along, right with you. and that all the work and struggle and acquisition and desire and practice was just to bring you back into this moment right now. And then we get into some of the work of Illich from there. But we're here right now, we're with Coogan, and I want to introduce him in an effort to kick off well into these two kind of related topics. First, just like what has it meant to scale? And then what do we think this does in terms of our capacity to scale principled games on some of the things that are being built in Web3. And by way of background, Coogan, I got to meet in a coffee shop in 2017, I believe, maybe 2018, in Austin, Texas. And I was always just blown away by his ability to listen and his respect for what's required to really teach, which is to say that, like, I think Coogan is one of the most voracious learners that I've gotten to spend time with, and that he's always put himself in a position where he's always learning and teaching as long as I've known him, which is now over half a decade. And so for him to be with us talking about scaling, where he was head of education at ZK Sync, he's also spent a lot of time educating in the Web3 space. He's been around since 2011, but specifically, I've known him teaching at Consensus Academy and now with the ZK Sync ecosystem for some time. And we'll have him here to talk about his approaches to scaling, what he's learned along the way, and what that might encourage us into conversation about today. So thanks, Coogan, for being here and for being with us.
Oh, it is such a pleasure and such an honor. As Vivek mentioned, we met each other in Austin in 2018, and Vivek is probably one of my oldest friends in the crypto space, and I couldn't ask for a kinder, sweeter person. And Kernel is such a really cool program. You guys are in a really special place. Nothing is perfect, obviously, but spaces like Kernel are really special in our world, I think, especially in our very digital world. So I'm so grateful to be here today with you all. I'm really excited to sort of dive in. I can share this deck just to sort of set expectations just for what the next little bit of time is going to be. So I'll probably take about 10 to 15 minutes walking through a very let's call it like a very technical sort of like actually sort of discussing scaling for blockchain networks. But I'm also very interested in all the work and the thinking that Vivek just mentioned. So we're also going to make some time for that discussion as well. So I'll do a brief introduction just around myself, just to give you a sense of my work. We'll talk through some of the sort of the current sort of roadmap for scaling Ethereum in particular. And then we'll discuss a mental model, and then we'll sort of turn it over to a discussion. Please feel free to pop in. I'll watch the chat. I love watching chats, so I'll keep this open as best I can. I also want to say hi to Elizabeth. Elizabeth is here on the call. Elizabeth is a very dear friend of mine. My children call her Auntie Lizzie. She's in KB9. So I see her in the participant. I just want to give a quick shout out to Auntie Lizzie since she's here.
Love you, Coogan.
I love you. I'm so happy to see you. All right, there we go. All right. All right. So can everyone see this now?
We can.
Okay, great. So quick, just like a little bit of background about me. Like Vivek said, I actually discovered crypto. I was working as a tailor, like I was making clothes in a left-wing anarchist bookstore in Charlottesville, Virginia, where I actually am right now. And someone came in, and I worked a lot in alternative economies. So like I didn't take sort of strict payment from people. People could pay me what they wanted to, which worked out very well when like my cost of living was very low because I was dumpster diving and sort of, really just sort of living a very alternative lifestyle. and someone came into the bookstore. I was doing a work share, so I'd work at the bookstore, and then I'd also tailor clothes when I wasn't working at the bookstore in a space in the bookstore. And they told me about Bitcoin, and this was 2011. And I said, "This is awful. This is very terrible. That all this technology is not good, not promising at all." But I'm always very curious, and I love just sort of following things. And so I just fell down the rabbit hole and kept on learning more and more. And then, Bitcoin was going along, and then Ethereum came out, and I thought, no, this is a really bad idea. I was like, this is like even worse. What a worse idea than Bitcoin. But kind of fell further and further down the wormhole. So really, the trend here is that I'm not very good at sort of identifying things in the moment. No, that's not the trend. So, anyways, so all that to say, I ended up actually getting quite involved in crypto. I moved to Austin, Texas, with my now wife, and I started teaching in workshops in the area around coding. So I was doing tailoring, but then I switched to doing coding. I was doing a lot of design and then switched to coding. And one of the things that I really loved doing was just sort of teaching and sort of describing this technology. And one of the things that is so exciting about crypto even now is that there are not many people who are senior developers, so to speak. It's been around for quite some time. That is, like, now there are senior developers, but the space is still very new. Things are still evolving very quickly. So I always tell students, I'm just a few Google searches ahead of you. And really, the kind of the real craft that I have worked on and continue to work on is learning to learn, which is sort of appropriate for this section here. So that's just a little bit of background there. I worked at a company called Consensus, where Vivek and I, actually, we were colleagues there, and then uh, um, Kernel and Gitcoin spun out, and we obviously continued to work closely together and be in contact and aware of the efforts there. And I ran the Consensus Developer Bootcamp, and then after about 4 years, in January 2023, I moved over to a company called Matter Labs, which runs a layer two. And we'll get into what a layer two is. And specifically, they run a zero knowledge L2. So it's called ZK Sync. And we can discuss it in a minute here. Part of my sort of work, I was head of education at ZK Sync. Last week was actually my last week at ZK Sync. And so for about a year and a half, I was working to develop a common understanding of what layer twos are and zero knowledge, what are called ZK VMs, this specific kind of operating system that's going to scale Ethereum and other public blockchain networks, as well as zero knowledge proofs, which are these really exciting sort of new forms of math that are getting developed as we speak. And we can get into those in a minute as well. So I ran this developer bootcamp here in 2023, fall of 2023. Earlier this year, we put on a workshop series through Blockchain at Berkeley. I know there are some Berkeley folks in the kernel. Always feel free to pop in. It sounds like maybe an accidental unmuting, but no worries. Pop in with questions, or I'll also check the chat. Let's see here. I'm watching the chat here. Good. Okay. Alrighty. So yes. So this was a lecture series that we gave at UC Berkeley, but it's representative. We worked with a lot of universities around the world. Mainly this was sort of just sort of trying to provide mental models for people to think about layer twos. People are relatively familiar with blockchain networks now because of the great work that Kernel has done and other folks in the space in terms of educating folks around the sort of the fundamentals. But we wanted to sort of introduce that in for layer twos and zero knowledge proofs as well. So this is a typical lecture series that we would pair with a world-class organization, and the students would actually teach the material. And on the left-hand side, this is IIT Delhi. This is our first lecture here that we gave there as part of our lecture series. They did I think something like a 16-week long boot camp, which was exciting. And then on the right-hand side, we have UC Berkeley, Blockchain at Berkeley students attending their first lecture there as well for our lecture series. So along with very technical material, we also did a lot of really fun stuff, and I'm excited to sort of talk about this more. We made this board book, this sort of like vintage style board book called EL5 Zero Knowledge Proofs. and it was like a kid's story. You can actually go to the website here. I'll put it in the chat. Actually, I'll share it right here. It's el5.zksync.io. If you go here, I'll put it in the chat as well. There we go. So this is like, again, just sort of a way of explaining what zero knowledge proofs are in a very approachable way. And what was fun about this is that even though it's EL5, the sort of explain it like I'm five is like a trope from Reddit and from the internet uh, that has have broader implications now. But it actually takes quite a bit of foundational knowledge to explain something to a 5-year-old. It seems a bit counterintuitive, but it became like it became like the skeleton key that helped me unlock how to make this technology, which everyone from Vitalik to, these brilliant minds have struggled to explain the math behind zero knowledge proofs. And we kind of stumbled upon this way of doing it, which I find this book is really popular and very fun. We have a volume 2 that we're hopefully going to be able to do for DevCon this year, which I'm really excited about for modular arithmetic, which is really fun. And then the real thing, though, which I was so stoked about, is that for ECC, we actually made a video game based teaching people how to do zero knowledge circuits, ZK circuits. And it was this whole narrative around Zeke, who's like our sort of our network mascot, and his daughter, who take care of this zoo with all these different animals called Mathimals. And you can solve these circuits, which are the sort of the building blocks of zero knowledge proofs and ZK EVM. So this is an actual game that my team made, which is so fun. If you want, I can share sort of a private link to do. They're meant to be played in person. We're going to do a wider release around DevCon. And but anyways, this was like, for me, this was such a sweet way to teach these circuits, which are so hard. But we worked with we have like world-class cryptographers who are very talented and gave us a lot of their time. And a lot of it went into this. So that was so much fun. And I'd be happy to share that with folks later. Okay. There we go. All right. So now we are going to, because this is a sort of a module about scaling, I did want to just take a minute. Do people have any questions, by the way, just before we kind of hop on? Oh, you have a copy of the book? Oh, that's fantastic.
Mostly happiness, no questions.
Okay. All right. Wonderful. I'll watch the chat here and happy to stop whenever. Okay. So I use a lot of jargony terminology that some people might understand, but hopefully a lot of people do not understand. Just I say hopefully, just in the sense that like I do think it's very, very important to define terms very clearly, and I use a lot of terms like L2s and zero knowledge proofs and ZK and all this sort of stuff, which is jargon. So I want to sort of go back and really sort of explain what are layer twos and why they're important, and how they fit into the trend of distributed systems that you all have learned about over the past few weeks. Okay, so Bitcoin, first widespread application, and had this core innovation called the proof of work consensus. And when I taught blockchain developer boot camps, I made a really big point to teach what I thought were like just sort of, regardless of whether or not you stayed in cryptocurrency or Web3 stuff, this was valuable, valuable knowledge you were getting. And proof of work consensus, also sometimes called Nakamoto consensus, is actually solves an outstanding problem in mathematics, specifically in cryptography. And that is really important. Like that is something that will persist throughout time, regardless of what happens to cryptocurrencies. And that was a huge deal. It's very easy to forget now, but when I was meeting, when Vivek and I were meeting in Austin to talk about this stuff, the narrative wasn't these are sort of scams or rug pulls. The question was, this is magic internet money that's not going to exist. That somehow this is going to be hacked, or that the protocol wasn't secure, or it didn't work to distribute networks in this way and try to attach value to it would be too expensive. And so it's really important to note that Bitcoin and then Ethereum later, which was generalizing Bitcoin with more programming and execution, but essentially sort of the same fundamentals. These were radical experiments. We take them for granted now because they're reported in the Wall Street Journal or there's on Twitter, there's all this sort of stuff. But it's so important to underline that this was not guaranteed to work, A, and then B, it wasn't guaranteed to be safe. And again, there are plenty of rug pulls, there are plenty of frauds, there are plenty of solidity errors that cause huge losses for people and have devastated lives, absolutely. But the core protocols themselves have not been hacked. And when you look at sort of, however many hundreds of billions of whatever of money is secured by it, which is in Bitcoin or Ethereum, you can see those as bug bounties, right? And the fact that they still exist now proves that, even the most dedicated people or hackers are not able to break the system. I just want to make sure if someone has a question they can ask. Okay. So that's really important to underline. These are huge monumental achievements, literally in terms of like information systems and cryptography, huge innovations around proof of work consensus and distributed systems. However, if you're building a startup or if you're building a project, there's a distinct difference between proving a concept correct, which is distributed trustless consensus or distributed consensus amongst strangers, and then actually making it production level. And that is sort of the way that I see where cryptocurrencies are now, that we've spent the past decade or so showing that these systems are secure, that they are somewhat reliable in terms of they're not going to break. However, they're not widely adopted, right? It's really important to be clear-eyed about this. And it's pretty clear why. Obviously, accessibility is a big issue, but as Vivek was mentioning earlier, that there's a cost of transactions and there's a slowness around the process as well. Essentially, the concept is good. People say, yes, this is really important. We need to, this idea of being able to send money quickly across borders is an obvious pain point in a lot of different ways. How can we scale this up? And then you can obviously then just sort of extrapolate out for identity and games and all these sorts of participatory online examples. So adoption is not widespread because of that. So the view that Ethereum has now, so Ethereum core developments, particularly, in particular, the core developers, is using something called a layer two. And we'll get in specifically as to what that is, but this is actually, this is from the first DevCon, and it's a panel on scalability, and it's specifically about layer twos. So the point of showing this is that, even back in 2015, at the very beginning were discussions around how are we going to scale this? It certainly will be layer twos. So even though they've become quite popular over the past couple of years, even 10 years ago, this was a discussion that was happening in the community itself at the first DevCon. And then in October 2020, this is a post from a website called Ethereum Magicians, which is where people post there's a lot of technical discussion that happens around protocol changes to Ethereum. This was a post by Vitalik Buterin that was what would a roll-up centric Ethereum roadmap look like, and essentially sort of postulating we're having trouble scaling Ethereum. We have a couple ideas around how we can do it. However, it looks as though roll-ups, which is another term for layer twos, would be a good way to scale Ethereum. And this is 2020, but as earlier this year, there was essentially sort of a major protocol change that sort of confirmed that, yes, Ethereum is going to use layer twos, which are also called rollups, and we'll get into that in just a second, as a way to achieve that sort of production scalability. So again, if we take sort of proof of work and sort of early days of Ethereum as proof of concept that these things work, right? That you can do proof of work and then you can do staking with the merge. Now the question is, how do we kind of build this out and we make this more robust? And the question is, Ethereum has like planted their flag. We said, okay, now we're going to use these L2s. We're going to use these rollups. Okay. Any questions about that before I go? I think I'm running a little bit slow on time, so I just want to be mindful of that.
Why don't you keep going? Because one question is just like more on layer two roll-ups. So here we go on
Great.
that. And then a couple. coming through. But keep it going, I
Great.
think, Coogan.
Okay. All right. That sounds great. Let me just make sure okay. Okay, great. Mm-hmm. That's super interesting. Okay, yes, all good questions. Okay, cool. Yes, okay, great. Okay. So what is an L2? When I say an L2, what we mean is a layer two. And so a good way to think about an L1 is one ride is like a toll booth on a bridge for a city, right? So if you are one driver in a car going onto a bridge, you have to pay one toll, right? And it's relatively expensive. However, if you were to carry a lot of people in your car, and you could distribute that toll over the number of riders in your car, that cost would go down dramatically. It also would sort of reduce the amount of time. If you think about, the same number of people in individual cars versus putting all those people on a bus, for example, much quicker to move people through the city. L2s are a similar concept, right? So we're trying to scale these blockchains while keeping them secure as the L1. Now, when we refer to L1 here, this is layer one. So if you think about two networks, L1 is traditionally Ethereum, although other networks are now being explored. And then the layer two and L2 is the network that is on top of Ethereum, but is related to it. And I'll explain that right here in just a second. So imagine we're on an L2, a layer two. We have a number of different transactions. Those transactions get consolidated into a single block on the L2. Let's say it's ZK Sync or other L2s are StarkNet or Scroll or Optimism or Arbitrum. These are all layer twos that exist. You do transactions on there. They get compressed down into a single block, and then that block is verified on the layer one on Ethereum. And those blocks to the layer one can be seen as checkpoints. And those checkpoints provide security backstops. So if anything happens to the network, so here's our block that's been verified on Ethereum. Let's say something happens in this block and it doesn't get verified. Luckily, we have this backstop that's been created on Ethereum. So all the actors can always kind of wind things back and sort of unlock the system right here and exit the system trustlessly. This is a big sort of aspect of layer twos is you create these security checkpoints on layer one on Ethereum, typically in a smart contract, always in a smart contract. And there's smart contract logic, which allows you as the L2 user to take your own data, go to the L1, and then unlock your funds. It's a dramatic it's called an exit, and it's quite challenging. However, it's really, really important to figure this out because that's how we get away with doing scalability on the layer two is that we have that sort of security guarantee of the L1. You can always go to the smart contract on the L1 and exit. So another analogy, which is helpful for folks sometimes, is like a gift card analogy. So let's say that Vivek runs a deli that I really like, and I go to him and I say, I'm here every day. I pay with my credit card, but there's a credit card fee associated with this. It might be easier just for us to do. Let me just buy a gift card for $20, and that'll be one purchase, and I can buy breakfast for the next 5 or 6 days. Vivek says, great, that's wonderful. We do an exchange of legal tender, right? So like we sort of lock in funds there. I get this plastic card. And then over the next couple of days, I'm doing transactions on that card. Now, if you imagine the legal tender, let's say I paid with a US dollar, we're not doing it in dollars, right? We're sort of operating on this sort of liminal sort of other network, right? We can exit. And if I want to exit and say, hey, listen, can I cash out this gift card? Vivek would say, absolutely. And let's say he gives me back an incorrect amount. We can both say, hey, actually, let's go back and look at the receipts because it's pretty clear that like I bought this on this day, which brought my balance here. You can do kind of like a sort of a comparison. So it's a similar sort of role there between the L2 and the L1 of like a vendor and someone who's purchasing a gift card, if that helps at all. Now, this is really important because going back to the toll booth analogy, the more transactions we can pack up here into a single sort of verification on L1, the cheaper things have. And this is a screenshot from a couple months ago. And you can see here, just to send ETH on Ethereum at whenever the snapshot was taken, it's about 80 cents, right? However, there are a couple other L2s up here, which sending ETH, and it's, a fraction of a cent. It needs to be lower, just to be clear, but it's much, much lower than Ethereum mainnet. And that is because we're sort of taking advantage of these economies of scale of the L2s, and which are backed by the security guarantee of the L1. So it's a lower transaction fee. It's also faster. I won't get too much into this, but if people are familiar with this idea, which actually comes from distributed systems just in general in computer science, um, the sort of the challenge of an Ethereum or a Bitcoin scaling is that you can only sort of like you can either be highly decentralized, meaning you have a lot of people who are validating the system. You can be scalable, meaning you have a high transaction throughput, or you're secure, meaning that like the security guarantees and the sort of those backstops are really strong. Typically, it's thought about that you can only have two out of the three here. But the idea here is that if rollups are able to provide that security guarantee on the L1, then they quote unquote solve this blockchain trilemma, right? They introduce scalability on the layer one while sort of maintaining this high transaction throughput, but the security of the L1. And okay, so I'll stop there just for now because there's a lot of information. I think there are a couple good questions here. So I'll just pause here, and I have like one more little takeaway here. So, all right, let me see here. Okay, I'll start at the very beginning. It says, okay, so Grace asks, adoption question. If crypto systems become adopted by many people, do we end up in a hyperinflationary environment because of the ease of printing money? We're seeing that with meme coins. The only real use for real people is creating money out of thin air, and that particular function creates devaluation of all crypto assets. So it's an interesting question. I'm not a monetary expert, and so I won't speak too much about sort of inflationary environments. I personally think the monetary argument around cryptocurrency systems isn't particularly well thought out, more so than it's sort of articulated. However, I do think that just in terms of stable coins, let's say, um, that which is a little bit cheating, right? Because you're sort of borrowing someone else's currency. I think that the sort of the goal, the best use case that we see right now is actually on Tron. Tron handles a tremendous amount of remittance payments in Southeast Asia, like hundreds of billions of dollars are processed on Tron because it's just very cheap to do so. And so that usage has not led to the kind of devaluation. If anything, it sort of like proves the value of the network. But I do hear what you're saying about meme coins, and there's obviously a concern there around around sort of financial scams, which unfortunately I think are rife in the space. So it's a little bit of two things there. I'm not sure I properly answered. Okay.
Yeah.
Okay.
You just bumped one up from Camila, which I can read too, if it's
Okay.
helpful, Coogan.
Sure. Yeah.
It's from Camila. What data is there around the blockers around people onboarding into Web3 dApps? As a designer and someone in this space, I agree that poor design and education, along with its novelty, impacts adoption. Curious about organizations or projects out there that have notable research around this.
Yeah. Yeah, it's a great question. So I think the question there is that I made a statement saying that there are blockers around people. So what is preventing Web3 adoption? And I think the question is, or saying that sort of agreeing with sort of the assumptions there. I know that there have been a number of UX design teams. Consensus actually had a really strong UX design team for a number of years. And then MetaMask also has a very strong UX team, which is at least a dozen people working on this sort of design challenge. And I think we can track down the people who are part of that team, who head up that team at MetaMask, because I think they would have probably a ton of great information. Um, that was sort of my experience at Consensus. Was MetaMask really needed to figure out sort of UX sort of challenges around wallets like that. That's where I've seen the most amount of data around adoption is people, setting up wallets, using wallets, that sort of thing. less so on the developer side in terms of adoption. So I think, yeah, you can sort of see proxies for it just in terms of Coinbase developing their own wallet, which is all in browser, the sort of the rise of like in browser sort of activities, in browser wallets or in browser sort of on chain activity where people don't even see the keys, even though they're sort of secured by passkey on their phones or things like that. So yeah.
Yeah, and a lot of these wallets too, they're benefiting from these numbers that you put on the screen of like a lot of them are layer twos, right? Or are tied into layer twos, or they're
Right.
benefiting from the fact that layer twos now have sometimes a cent in gas fees instead of 80 cents or $4 for swapping tokens. Sometimes it's in the 10-cent range. So that's a big part of what people have talked about for a long time is somewhere in between those two worlds. But yeah,
Yeah.
maybe we can keep
Yeah.
going for
Last
next.
question, and there's a last question from Grace, which is really strong, which is important to go back to, which is that uh, the question is, how do you achieve sustainability when your fees are really low? It is a very good question. Um, that was one of the more interesting sort of aspects. Um, is that yeah, I think it's a real challenge that a lot of L2s are struggling with. I saw discussions both with our team at Matter Labs, but then also with other teams as well. Certain teams were subsidizing. There's sort of like a sort of an understanding that you can really kind of subsidize your user fees. A lot of people talk about free transactions as well, and that feels to me like a loss leader sort of tactic. And so, yeah, I think it's a really good point. Honestly, I don't have a good answer to it, but I just want to sort of highlight that it's a great question. The question being, how do you kind of maintain a company if you have these sort of low fees? The way that I've seen that a lot of big projects such as Arbitrum and Optimism and Matter Labs for ZK Sync and Polygon are dealing with it is the idea of being able to provide app chains. So specific projects such as Base from Coinbase is actually built on Optimism. So Optimism gets a certain amount of uh, uh, what's the term? It's like sort of like licensing payments essentially. It's like hard coded into the Base protocol that a certain amount goes back to Optimism, which then Optimism distributes through their retro public goods funding. And Yeah, so that is sort of the current business use case, I think, is that you sort of see your public L2 as your proof of concept and sort of the good, or not proof of concept, but like the sort of like the featured model. And then if people need to build their own L2 and kind of tweak parameters. So for example, if they want to store their data elsewhere, if they want to use a custom base token, you can provide that sort of customization. And then that is a business line as well. So yeah, it's a good question. I think that's the current way that people are thinking about it. But yeah.
Definitely. I want to make sure we get to the universal mental model, Coogan, because
Yes,
I
let's
think
do
it's
it.
just
Oh, Universal Mental Model. Okay, got it. Yeah, so I'm gonna
yeah.
drop an image on everyone. Um, and it's like a whole lecture series. Like when we do it at universities, we spend like a whole lecture on it. So I'm gonna drop it, but I don't want to scare anybody. So the idea here is that L2s are the future of Ethereum scalability. However, it was when I first joined Matter Labs back about 18 months ago, a year and a half ago, it wasn't actually clear what an L2 was, what different sort of core components were. So one of my first kind of exercises was to create a universal mental model for all layer twos. So the idea here was to capture critical elements that make an L2 with the hope of highlighting design trade spaces is like a nice term of art that I've heard, which is essentially sort of ways in which different L2s do things differently. Like how do you compare L2s, right? You sort of need to sort of understand where the different sort of design choke points are, and sort of say, okay, Arbitrum does it like this, Optimism does it like this, ZK Sync does it like this, and there are positives and negatives to all those different sorts of things. I just want to make that really clear that it's not as though you're saying this is bad or this is good. But mainly just sort of understanding where the sort of like I always see it as like flags, places to point people. And so yeah, this is the universal mental model for layer 2 networks that we came up with. This is after speaking with a lot of engineers, showing this, talking to everybody in the space, and kind of finding a um, yeah, finding sort of the common points that are here. So there are a couple of sort of elements on here. There also are, and I wanted to grab my speaker notes just so I don't so I get this right. Yeah, speaker notes here. There are also sort of three sort of main questions that you can ask to start to unspool this design space and sort of find sort of start asking the right questions, and then getting a sense of what a network is like. The first one is a network optimistic or is it based on ZK? So that's sort of the main genre right now of ways that networks compute and aggregate their network state. So this is how do you create those blocks, which then go down to the layer 1. There are different ways that networks do that. One is optimistic, the other is ZK. The second is, where is the network data stored? So another way, a more technical way of saying that is, what are its data availability layers? Typically, that's, for public L2s, that's Ethereum. Kind of Ethereum is your layer 1, but other networks use other blockchains, or maybe even sort of a private server for your data if it's appropriate. And then the last one is, how do L2 users communicate with an L1? The thinking here is both what data is the L2 publishing to the L1, and more importantly, what are the dispute mechanisms for an L2 user to communicate with the sort of security mechanisms on the L1? Quite frankly, right now, this sort of like forced exit, or this sort of like this exit model is not implemented. I don't think it's implemented on any L2 right now. It's in the roadmap. It's definitely coming, but it's sort of like this like sort of interesting sort of dynamic right now, where right now it is sort of, it's based on there are security measures in place, but in terms of allowing a user to just go and unlock their own funds on an L1 smart contract, those are not available right now. So it's really important to understand what that dynamic is like in a network, how they're going to solve that, how they solve it now in lieu of not having that sort of direct method of dispute. There are a lot of really strong security guarantees. I'm not sort of saying that this is sort of like exposing some sort of weakness in the network. People use a sort of a security council. They have an update window where there's a certain amount of time before updates are submitted. There's a lot of fail safes, but it's not a proper L2 yet. And L2 Beat has done a lot of really great work on that. The website L2 Beat, around sort of pushing networks to live up to this element of the L2, because just to sort of underline the point, we do not get the scalability effects of L2s if we don't have the security feature on an L1. So it's really, really important to do it. Okay. I'm going to take a little bit of honey right here. I'm going to take a quick bite of honey so my throat is not sore.
Coogan, thank you so much
And then I'll
for
go, yeah.
this depth. I think, just to reiterate, I put it in the chat. I hope that that's okay, but it's just like such a clear set of questions to understand the different layer 2s, and there are ways to go a bit deeper and say, okay, what's this one doing? What's that one doing? What do we feel most excited about in terms of the approaches? But this is a really, really healthy place to start. Is it optimistic or is it ZK? Where is the data stored? And what are the data availability layers? It's led to like a whole nother branch of research that's sprung up in recent times. And then how do L2 users communicate with L1? And it's nice to note on the communication between, it's like, okay, what are the normal state root updates? Just like what goes on every single transaction. That's an interesting thing. I don't really know personally the differences between the different L2s on that. And then this point on dispute mechanisms, it's one thing just to do the regular state root updates, so just passing the information back to the L1. But when things go wrong, when there are transactions that are, let's say, adversarial, which is a big part of the system is that, you know, you're building the systems with a hopefully a defender's advantage. So like what are the dispute mechanisms becomes a nice and important question. So just great ways to think about L2s and really clear. So thank you for sharing them.
Yeah, absolutely. Totally. And just it's interesting too that like ZK, all networks do it differently. You know, it's like an API endpoint for a software. It's like even ZK rollups do their state root updates really differently. So it's just like it's just good to know. It's just good. It's a rich, you know, it's just like a rich data. You know, it's just like a good place to start answering questions, start asking questions.
Amazing. I think there's been some really healthy chat around um, lots of different things. I think my instinct just for a moment, Coogan, is to just talk about like the process here for you. Like how did you come to create this mental model? And yeah, what can you say about like how it grew and how it developed and the really the practices that you put into place to develop learning models like this um and other models that you think might be interesting for people to explore.
Yeah, absolutely. And this definitely goes to the uncensored learning and sort of learning to learn. Um, this actually came about, my colleague Tom Hay and I sort of realized how important mental models were for when we were teaching the blockchain developer bootcamp. And this was the first sort of uh, this is the first this really clicked for me in terms of how important mental models are, especially for emerging technology, because you know we would have people who were there weren't really Web3 developers when we were doing this boot camp initially, and so people were coming in from Web2 and they were just drinking from the fire hose, as I'm sure all you all have experienced as well. There's just so much to kind of learn um, in the crypto space, and so we would give people information or we would even start the course, and a week later, the course would be broken because Arbitrum would change how they were doing certain things, or you know, MetaMask would change some sort of, you know, like just like the rate of change was so high that like even when we were building this course, so then we sort of moved away from okay, it's important to have information, it's important to get people up to date, but what's really important is to give people a map, to give people a sort of a lattice and a structure on which to hang knowledge, and so sort of what we were able to provide in this boot camp was a mental model for blockchain development. You know, this is node development, this is execution environments, this is security, this is sort of second order effects, right? How do you build DAOs and DeFi and all this stuff from these tools that you just built in the execution environment? You know, how do you sort of operate? You know, so we found that enormously helpful for students. And so coming into this space, you know, as sort of Matter Labs, and they were wanting to sort of do education, it became really clear to me that that me personally, I did not have a mental model for this. And so the exercise, this was 100% something that I wanted to do for myself and that I could see other people benefiting from as well. And that's definitely been borne out as well. Not all my ideas are like that. A lot of my ideas are like just I'm the only one kind of interested in that. And sometimes that's good, but you know, for this case though, I wanted something to be broadly applicable, and I do think that's been borne out. The part that I wanted to mention is, oh yes, there's a wonderful quote, which is that all graphs lie, but some graphs are useful. And so it's really important to note that any sort of layer of abstraction that a mental model like this is doing, we're missing some subtlety, right? That it's like there's something missing here. The point is this helpful? Is it useful? Does it give you a sort of a little bit of a buoy or a life raft to float on while you're trying to get your bearings in the middle of this ocean? And so that's sort of always the goal for these mental models is are you providing just sort of a lattice on which someone can just sort of hold on while they're getting up to speed? And then hopefully, you know, my favorite part is when people sort of start to sort of say, I think this part of the mental model needs to be refined. I think this is actually incorrect because I went and learned, and then, I now I'm looking back and this part is not helpful or whatever. And so we adjust it. That was the most helpful part of it. So that's really important. And then the last thing that I wanted to say, and Vivek and I talked about this a little bit, which was, um, I'm sort of taking advantage of being a teacher and presenting a mental model, right? By saying this is a universal mental model, I'm playing with the idea that I give a lecture and people are looking at me and I'm an expert. However, my expertise only comes from as compelling and as valuable the educational material that I'm contributing is to folks. And so it's very, very important to understand that there's nothing preventing you from making a mental model, a universal mental model for layer twos that looks very different from mine, right? That like I am not, this is not something that like I meditated and then it came to me from the ether, right? This is something um that is like kind of explored. I kind of see it more as like, like you're taking a lot of data points and like trying to sort of infer structure. And then you sort of mock up the structure. You're almost seeing like the negative space, right? You say, oh, it kind of looks like there's a line there, maybe. And you build a structure and you look and you compare it. It's not quite right. You sort of do this thing, right? So it's like, it's fun to present these sort of monolithic things. I get a big kick out of that because I have a pretty big ego, and so it's like fun to sort of present a universal mental model for something, right? But in actuality, this is something that is sort of it's only as meaningful as it is helpful. So
It's growing local. It's growing through like one conversation at a time and updating and changing. Yeah, but thank you for describing it and the lattice and all of the things. I want to open it up to discussion, other voices. There's so much good stuff in the chat. Please, maybe we kind of go back and forth into discussion, and Coogan can help stoke the fire. But if there are any other people that want to respond to each other, discussion can kind of be open-ended, and we can give Coogan a chance to just kind of like have some honey and enjoy the time. But maybe, I mean, I know Clifford, I know Fabian, there was just a lot of like good chatter in there. Maybe there's a good place to start there if y'all are up for it. Just like what you found and what was going on in the chat there. Almond has a question, so just anyone who'd like to kick us off would be willing.
I had posted that link to the UX MetaMask case study, and I've just kind of been thinking. This might be a little bit off topic here, but I've just been kind of thinking about UX and the design of how we interact with these technologies, almost as kind of like it's like a new dimension of prosthesis design and like prosthesis ergonomics. It's kind of like the psycho-spiritual ergonomics of these technologies. And I feel like so much of the problem we're having with all of these technologies is that we're like just figuring this out. Like we're already cyborgs. We're interfacing with these things on such a crazy level, but it's like harming us to use them still, or it's like hard for people to get into it. Anyway, so this is a little bit off topic and not really a question, but for those also interested in this kind of UX, and I saw Winter talking about how they're interested in UX as a way to get people into third spaces. I thought that was a really interesting idea too.
Yeah. Thank you, Cliff, for kicking us off. Yeah, absolutely. You're gonna have to put prosthesis ergonomics in the chat, perhaps something to come back to. But I love the word, especially. I want to learn what prosthesis means, I think, but ergonomics as a suggestion, as a design practice here is really interesting use of words.
Just prosthesis in the sense that we're using these things to extend our abilities and to build ourselves out, kind of.
Nice, beautiful.
I have a quick question about L2s. broadly. I'm a fan of ZK for various reasons, over optimistic, but Coogan, what are we seeing, or anybody else, around adoption of apps on different types of L2s for different reasons? So segmentation based on the type of L2 because it's better suited for that type of activity. And is that the way we're moving, or are we totally not moving in that direction?
No, it's a great question. I think the first is um, the first question is, there's a distinctive change between optimistic and ZK. Like you said, there's this sort of meme going around, ZK is the end game, right? That uh, in terms of scaling, ZK provides more clear scaling benefits to optimistic rollups. The thing is that people did not believe that ZK technology was going to advance as rapidly as it did. Like that sort of caught a lot of people by surprise. I think people in ZK networks were surprised about how quickly they came online. So optimistic networks were built initially as like a stopgap measure, and sort of everyone sort of understands that we need to move towards ZK networks. So just sort of broadly speaking, there's that sort of decision. But to your other question about sort of people deciding, sort of segmenting, for sure, depending on your use case, I've seen people, and this is sort of a little bit where the discussion, the sort of the mental model is around, particularly around data availability. I think that's sort of where data availability, and then whatever your sort of gas token or native token is. So I've seen people sort of optimize for data availability, which lowers your costs. So, if you're not posting, the number one cost for an L2 network is the proving cost, but then also publishing that proving cost to Ethereum. The transaction cost is almost directly related to, is supposed to be directly related to the cost of publishing the block to Ethereum. So if you can increase those blocks, if you increase the number of transactions, you lower the fees. However, if you're a game and it's not particularly important for you to need to settle to Ethereum, like the L3 discussion, is you can then do data availability somewhere else. Let's say it's some sort of short-lived sort of operation where you just need a weekend amount of data for a conference or something. Maybe you put that on a private server and it's no big deal as long as everyone settles, as long as you have your ZK proof or whatever sort of fraud proof, and you publish it, and people can use that to verify their transactions. You don't need the data necessarily. So people will optimize for that. And then the second thing that people optimize for is UX. And that involves everything from mainly sort of subsidizing user transactions, and then also doing kind of interesting things around account abstraction, moving away from a private key as a sort of the basis of private keys as the basis for accounts, like accounts be smart contracts, that sort of thing. Certain networks will optimize for that. Did that answer your question? I know those. I sort of like I think I got.
Yeah, totally does.
Helpful? Okay.
Yeah, and then I guess the only other question I have is, what are other networks doing that Ethereum is not doing around scalability that you like?
Yeah, I think the main one is that, I had a slide in here that I typically use, which is like L2s as playgrounds. Like I do think that Ethereum and Bitcoin are tanks. Like they can't stop, sort of. So it's okay that they move slow. That's no problem. We just don't want to introduce sort of like things that'll cause them to break very quickly. And so it's fun to see L2s as like playgrounds or as test tubes for different sort of use, both technology. And you can see that just genuinely in like using ZK proofs to do that sort of, to do that. It wouldn't have happened as quickly if it was if you were trying to build your own single network. If you're trying to build an L1 that's ZK based, It's much harder as opposed to if you're plugging into Ethereum, where you inherit kind of all the network activity and all the sort of the energy that's on that chain. So I think that's interesting. And then, I don't know if this is necessarily tied to L2s, but I think a lot of people are very excited about, just what I mentioned earlier about sort of account abstraction and kind of doing interesting things where essentially your private key doesn't necessarily have to be the only way that you access, that you can sort of do on-chain activities. Maybe you can do it from a browser and it's secure.
Yeah. I think these are all like really helpful notes because they're the cutting edge of the research and the questions on like, let's say, how the wallet interacts with the chain, how the data availability layer works. And also to me, I'm feeling a tie back to Grace's original question about just like, is it just going to be meme coins forever? And trying to remember in this module that we have scaling that we've been going pretty deep on, and then this principled games idea like down the list. And the first part to creating more principled games is just like setting up all the, it's almost like you're setting up all the board pieces and like creating them in such a way that at least the game is one where more and more people can play. And I think that's what layer twos have done in large part, and that they continue to do. But then there's also this element of it that has to do with continuing to nudge ourselves on like, well, what are the more interesting things that can be built now, given the new context, given the new structure. And I think, at least for me, Elizabeth, your questions trended me down those directions a bit. Just like, what are the differences between these chains? How can we use the understanding of those differences between them to decide like, okay, what's it best suited for? What are some interesting things that we can try there that may be better there than any other place we've seen? So
that really impacts like adoption. Like at ETH Denver this year, the mayor or the chief technology officer of Buenos Aires spoke about their municipal ID, which is on the blockchain now, right? And no abuela in Buenos Aires knows this. But the point is, like, it's what they have, and it's safer and it's more secure and all of these things. And I don't know, I mean, technically, I don't know, I can't remember how it works, but these are how I'm trying to think about explaining what blockchain is useful for to like people who aren't in the space, which goes back to the UX question always. Coogan has been an ongoing theme in our kernel. So I'm really interested in like how we differentiate which tools are the best suited for this solution, and what tools we need that we haven't built yet that would execute this solution better.
Yeah, just to that point, and to sort of the concern around meme coins, which I definitely hear, I think, and this is a little bit of a controversial take. So Matthias, my colleague at Matter Labs, this is the government of Buenos Aires is working with Matter Labs. Like we're the team that they built that on, and it's for this business called Quark ID, and it's very interesting. And exactly like you said, no abuela in Buenos Aires knows about it. And that, to me, I think, rather than retail, sort of understanding what retail sort of uses we have right now, which I think is sort of where some of the fretting around meme coins comes from, is like, is this the only retail solution? Meaning that like not a huge government or a huge project. I think in some ways that has made me more confident and more kind of like encouraged. Like seeing that use case, it almost single-handedly kind of reinvigorated my sort of belief in crypto, because exactly like you said, the government was like, we think this is really compelling. We think this is a good way to do it, and we're going to do it responsibly. We do it open source. It's like really very, very compelling. I also have to say, it is non-trivial that people can send money from their web browsers in a matter of clicks. Like, I know there's plenty of issues, there are plenty of concerns, but like, it is just so important not to forget that, setting up a browser setting up a wallet is you're giving bank accounts to people. And again, I'm well aware, like there's so much stuff that's fraught with our financial systems, that sort of thing. But when we were running these boot camps, or we were running these lecture series in Delhi, I needed to send the kids some money for catering or whatever. And if I had used my bank, it would have taken days and it probably would have been flagged. It would have been a problem. And I did it on Polygon using my wallet, and it took less than 30 seconds and they got it and it was no problem. And again, it's really easy to be like, yeah, whatever. That's just basic stuff. But like the world financial system is so it's so atrophied that like that is not nothing. You know what I mean? Like the remittance payments on Tron is like that's not nothing. I wish it was on another network. I wish it wasn't on Tron, but that's really significant. That's not to say that people, we definitely need to sort of be concerned about, sort of the blowback from meme coins. We definitely want to imagine kind of new realities, but it's also really important to sort of understand that like maybe these large infrastructure sort of projects that certain municipalities are doing are that's a very positive sign, in my opinion.
Yep. Yep. We technically have 8 minutes left on the calendar with you. We have 18 minutes on the overall event if you could stick around, but maybe we keep it moving with, I know, Almond, you had a question. There's a question.
Yes.
There's a
I
few
saw
more.
this. Yeah. Almond was asking about teaching non-technical folks. Did you want to do you want to ask the question, Almond, or I'm happy to answer it right now too?
No, it was basically it. I think we know that Web3 is a very technical space.
Yeah.
And I loved the examples that you gave at the beginning with the video game. So just curious on your perspective about the value of non-technical people, and what are your takes on maybe approaching to non-technical people with education?
Yeah, it's a really good question. And I think it's also really appropriate because the ZK stuff, I mean, I cannot emphasize to you how complicated all this sort of the tech behind it is, including to even audit these systems, we have to educate like, like the best Web3 auditing services shops in the space. We need to like kind of educate them about these sort of primitives and stuff. So it's really like the technical elements are so complicated, and there's so few people who understand it in the world, that in some ways we do risk losing the sort of the public distributed quality of a network if you're just having to trust less than 50 people in the world who truly understand this cryptographic stuff, which is cutting edge and it's very compelling. So I think first off, it's extremely critical that non-technical people have intuitions around this sort of technology and ideally are able to discuss it in a meaningful way. When Vivek and I were meeting in Austin in 2018, it was actually kind of hard to find someone, even in crypto, who could describe the difference between Ethereum and Bitcoin, Ethereum and Binance Smart Chain, Ethereum and Polygon. Now, there's still a lot to do, but like you can walk around a conference and people kind of intuitively understand the differences between public and private, between sort of like, permission stuff. There's an intuition there. We need to have those same intuitions around layer twos, and we need to have the same intuitions around cryptography and zero knowledge stuff for our people here, right? So because otherwise, then it's no different than saying, let's just trust this big tech person, right? We need to kind of really sort of do that. So first off, very, very important. Second off, I'll just sort of describe what I think is the most compelling part of the EL5 motif, why it was like became this skeleton key that I just wanted to use everywhere. When you start describing math to people, I cannot emphasize how fast people eyes glaze over and how quickly they're looking for the exit. Like I am a relatively like compelling person to talk. I can sort of gauge and I would start talking about this, and within seconds, people would just be like checking their watch and ready to get out of here, right? Because our sort of the way that we've always taught math has been very you know, has been very boring, essentially. But what's fun about something like EL5, what's fun about analogies, what's fun about all this stuff is that you start to short circuit the sort of the hard wiring that people formed in sort of primary schools, where, you know, they were taught that, you know, I don't know, that quadratic equations are super boring, which is honestly the way that I feel about it. I don't want to feel that way, but I just do, right? So what's fun about EL5 is to be able to short circuit that. If you start talking to people about zoos and animals and like, look at this animal that does math, people are like, what? Like first they're just confused, right? And you sort of like, you sort of like seize on it, you know, you sort of say, now that you're confused, let me sort of backdoor this, this thing. And yeah, so so that's what I think is kind of most compelling in a way for teaching non-technical folks is short circuiting people's brains. Because you don't want to don't use jargon. I use a lot of jargon in my presentation today. I apologize for that. You know, always describe things as though you're you know, that you're very like pretend like you're talking to somebody who doesn't really understand even like what language you're using, right? And then being able to use analogies and sort of find these motifs. Again, the EL5 thing, it's like that's just like a internet thing. You know, anyone can do an EL5, right? That's always really fun. And to be perfectly honest, ChatGPT does a fairly decent job about sort of giving you a list of analogies, which is a good starting point. It's not good at reasoning, so it's like can be hard, but it's a good starting place. So yeah.
Thank you.
Sorry,
Yeah,
Grace.
Coogan.
Grace had a question about
Yep.
what are optimistic networks. So yeah, let me answer that one really quick. So you know, we sort of discussed. Let me actually share let me share this one more time. So the question between optimistic and ZK is how do essentially kind of how do you prove if you go back to here? You know, we talked about sort of you have all these transactions that come in layer 2, and then you submit this proof, which then is your dispute mechanism on the layer 1, right? So there are two ways to submit that proof that a certain transaction happened on your network. One is the optimistic approach, and then the other is ZK. And optimistic is actually quite easy to describe because it's in the name itself. Optimistic assumes all the transactions are correct and then submits those transactions to the network. However, it doesn't it doesn't confirm those transactions until a certain wait period. There's a sort of what's called a fraud proof window, a window of time where anyone in the network can challenge a proof that's been submitted to the network. And this becomes a game theory economics where we say, okay, if we can sort of have, so anybody who submits an optimistic proof, you need to submit a stake with it as well. So it's incumbent on the person. The people who are submitting these optimistic proofs, they are checking them, right? It's not as though you don't check them, but you check them, but because it's don't trust, verify, you also put a stake, a financial stake, just like you do for Ethereum when you propose a block. And if someone finds an incorrect proof, you know, incorrect transaction, there's a process by which they can then say, I'm a pessimistic person and I don't believe this is true. And so I've checked it and now here's my proof. And there's a dispute process to then go through being able to sort of challenge, okay, here's this Merkle proof, here's this Merkle proof. You know, there's a dispute mechanism there. But the critical point is that optimistic networks assume all transactions submitted are correct, and then give a certain amount of time for that assumption to be challenged. The problem with this and why people say ZK is the end game is that this scales okay. It's not bad. However, the problem is that it doesn't scale. It continues to scale linearly. What I mean by that is that because of the dispute mechanism, you need to include all the transaction data contained in that block. So if you have a lot of transactions, that's a lot of data, and you can compress it, but the data still grows at a linear rate because there's no compression algorithm that will sort of be able to like logarithmically compressed data. Like if you look at the amount of data, it's like this. Whereas with zero knowledge proofs, at a certain point, you sort of cap out. Zero knowledge proofs, zero knowledge networks, and we won't get into the details, but they compress data differently because they have a different dispute mechanism. So this is why people say ZK is the end game, because the scaling for ZK is great. It's really wonderful. At a certain point, it just levels out, and you can have billions of transactions, and you still only need a small finite amount of data that does not scale linearly. Whereas with optimistic networks, that's not the case.
Amazing.
I sort of my chat isn't working super well, so if there's another question, Vivek, you just holler to me.
Maybe
I can also sort of provide a lot of. Oh, sorry. Go ahead. Yeah, go.
Yeah, Zaremba, if you'd like, and then maybe we have time for one more, if anyone else has.
So shall I ask my question?
Yeah,
Yes,
please.
So I'm very curious about what do you think ultimately should be the state of sort of who is responsible to have information, to find information, or to provide information, in the sense of if there is a user of a tool, does that person do they have responsibility to find all information themselves, or can they rely on somebody else's, on the tool provider? Because so this is actually connected to what I was writing sometime earlier. If you think about like traditional finance, if you have a retail client, then the financial institution that deals with retail clients have the responsibility to provide them all necessary information. And
Right.
if they don't, if they sell something without providing all necessary information, then they can be liable to, and I forgot how do you grammatically.
Right.
put
But
that,
yeah,
but-
you're required to give all data, all relevant information. Yeah.
And that also comes with, so the providing information also comes with some sort of insurance that it's up to the tool provider to make sure that it works. So in crypto, there like in Web3, I think there starts to be introduced this idea of intent-centric design, but that's in a sort of a narrow context. I think in broad context, it's always that users have to learn everything, and if they misunderstand something, it's sort of like they're
on them,
bad luck.
kind of. Yeah.
So
What do you think?
Mhm.
Yeah, what do you think? Where do you think it should? How do you? Yeah, what do you think about that? I'm happy to answer it as well. I'm curious to hear your thoughts.
Yeah. So I think for a fully sort of wide adoption, I do think there should be this sort of retail client group who do not have to like find all of the information. And I think there should also be a full accessibility. So sort of if a person who maybe does not have a regular access to internet, so they're very disenfranchised, and they are maybe out of like a normal sort of like traditional banking and traditional financial institutions. I would love for them to be able to have access to those alternative institutions and alternative sort of money and alternative like social sort of constructions almost. But I think they should never be required to have all the information and to understand everything. They should be able to have trust in the tool providers.
Yeah, I think it's a really good question. I think there's also an important distinction between providing information and then making sure that information is known, right? Like technically I am provided with the disclaimer for when I have an Apple phone or whatever, but when I actually click agree, I never read it. So, there is this sort of the sense of you can provide information for folks, but unless it's clear what exactly is being, just because you're providing all the information doesn't actually mean that someone will be able to sort of process it, right?
I fully agree with that, but I also think that so sometimes people still don't know that they have that right. But
Right.
if for example, insurance missells a very like expensive life insurance to a
Mhm.
elderly person who
Right.
is
Yeah, of
extremely
course.
ill, then the insurance provider cannot sort of say that, oh, we've provided all of the information. If that information was not provided in such a way that it was possible for the user to understand, then it was not
Yeah.
properly provided.
Right.
So there's still, of course, area to dispute.
Right. Right.
Uh,
Right.
But
Yeah.
just providing information, if this is not something that can be easily digested, that's
Right.
also should not count as providing information.
Totally agree. Yeah, and I do think it's like on a gradient, really, that like, I have a seed phrase somewhere tucked away in my house that has, that's tied to a wallet. I cannot imagine that this abuela in Buenos Aires is going to also have a seed phrase that she has written down somewhere. So I do think what you're saying, and I think people in the chat are sort of echoing as well. It makes a lot of sense that UX is wildly underappreciated and it is so important for adoption. I do think it also is important to have the sliding scale, so if people do want to totally be, that that's available. But what I think sort of happened is we had those systems where it was so high security assumptions, but we sort of onboarded a lot of people who were not as savvy that you really do get a blowback, right now, which is challenging. So, yeah.
Yeah, yeah. I want to be mindful of time, and just kind of like leave some space for thanks for Coogan for sharing your thoughts, and for everybody for um, their inputs, and remembering some stuff from yesterday's Junso. And we have Justin here as well. I don't know if you're willing to share, but it's um, already in the chat. Just thought it might be a nice place to end. It was a really special part of the conversation yesterday as well. Justin, I'd be happy to pass it to you if you'd like.
Yeah, I'll read the poem. I think had a question for you too, Coogan, but I think it's maybe just nice to read it, and then maybe it'll come across in the right way. I don't have a lot of time, but it's the poem just says, yeah, and once those limits are understood, to understand that limitations no longer exist. Earth could be fair, and you and I must be free. Not to save the world in a glorious crusade, not to kill ourselves with a nameless gnawing pain, but to practice with all the skill of our being the art of making possible. And Coogan, as I listened to your story, man, I wondered from like being a tailor, working in this kind of bookstore and shop, and then moving into teaching and learning about zero knowledge proofs across sounds like the world, and education technology. I wonder like if there's something as like a closing note that you feel like all this work or that your life is really working toward making possible.
Oh, thanks very much for sharing that. And yeah, it's a really sweet sentiment, and really meaningful. Yeah, I think our world is still not so far from perfect, but I do think the reason why I find this work compelling is that I've worked in a lot of different groups, and the people who made Ethereum and even the people who made Bitcoin have created a new world. Whether or not it's perfect, whether or not you even like it, there are so few examples of people being able to create true new worlds where you can play and do new things. And in Ethereum's case, sort of this infinite garden, sort of like infinite play. And I just feel, I don't know if I have a purpose necessarily, but I do feel the thing that I find most compelling is being able to this infinite play, and the idea of sort of bending towards a more equitable and sort of, sort of more just world for sure. But yeah, and I think what's, again, it's not perfect. Like I have a lot of privilege and a lot of things that have really weighed into my favor. But the fact that it's by dint of learning, by dint of sort of exploring, and by dint of curiosity and maintaining curiosity in the face of challenging circumstances, that the world unspools in this really beautiful way. And I think that's been a fun thing to be able to experience. And I hope others get to experience that. And I hope I sort of am able to provide that for other folks as well.
Better place to end. Thank you, Justin. Thank you, Coogan. Thank you, everybody. It's always special to be here for Fireside. This is a real treat. So take care. Take care of yourself. We'll be in touch.
Thanks all.
See you very soon. Thank you. Bye-bye. Bye-bye. Bye-bye.
Bye, Vivek.